Yeah.
Yeah, so in terms of the diagram, I think it's come on a lot. Yeah. Um, I like the way that you've also incorporated the three different world perspectives on it as well. Um, um, I'll show you a few things that came to mind this morning. Yeah, if that's okay.
Yeah.
Um,
Yeah.
uh, it's
Sorry.
it's coming. Yeah.
Carry on.
Um,
Oh,
right.
you're screen sharing.
Yeah. Yeah. Um, what I'm going to do is I'm going to go through the the actual text you've written, and I'm going to put some comments in. Um, I'm just doing this so I can understand certain things. Yeah. So logical entailment and causal entailment, for instance. I wanted to get a deeper understanding of what that actually meant. Yeah. Um, so for instance, I was wondering if there was a relationship between logical entailment and theory and practice and causal entailment.
Yeah.
I got Chat GPT to give me its view on that. Yeah. Um, and but that's what I'm going to do. I'm going to go through it this morning, and I'll take time to give you proper feedback on that. Yeah.
Yeah. I mean, I can give you feedback on that
Okay.
instantly because it is rather simple
Hmm.
in at root. Basically, we're identifying Rosen's assumption
Hmm.
that from logical entailment you can infer causal entailment, but the two things are actually quite different. So that is an assumption
Hmm.
which he says is reasonable.
Okay.
Now, entailment is just a fancy name for implies.
Ah. Okay.
So if you think of two concepts, A and B, if A implies B, then
Hmm.
B is inside the Venn diagram of A.
Yeah. Yeah.
So if you go through the true false simple logic, in other words, not complicating things by thinking of degrees of truth, but it's just something is true or it's false.
Hmm.
Then if A is if you think of draw a Venn diagram and
Hmm.
think of B inside A,
Yeah.
you've captured it.
Okay.
Now, what you're saying is that relationship in theory is a logical one,
Hmm.
but in practice it's a causal one.
Hmm. Yeah.
And uh, that is the only basic assumption that Rosen suggests is reasonable to make. So
Hmm.
his natural law it's summed up by that.
Okay.
So all that ChatGPT is saying is a long way round
Hmm.
on thinking of a Venn diagram with A
Hmm.
and
Hmm.
B is necessary for A, so it has to be inside A
Okay.
on a Venn diagram, and that's all there is to it. It's actually quite simple at root, but
Yeah.
it sounds very complicated.
Yeah. 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 It's the it's the language that I wasn't used to. Yeah. So I wanted to get a better understanding of what it meant. Yeah. Okay.
Yeah, I mean, you see in books that A implies B is written
Mm,
as A hook B.
yeah.
That is, uh,
That's a logical entailment.
with the hook on its side.
Yeah.
Sometimes it's an arrow with a, sorry, an equals with an arrow,
Yeah.
a
Okay.
greater than sign at the end. But it just means A implies B.
Yeah. Okay.
the B isn't necessary for A, and you can't have A B without A.
Right. Okay.
Does that help?
Yeah, it does. Yeah, it does help. Yeah. Right. I'll show this one. Yeah. So the in this model, I've actually got a central element as well, and this also reflects the 5 Chinese elements. Yeah. And I was puzzling over what this 5th one actually is. Yeah. And I've explained the story before. So everything in the universe is a source and sink of signals, and this is showing the source of the signals, if you like. Yeah. And now we've got signaling where there's actually an interaction taking place. So there's signaling from one to another in terms of parts. And then there's an impact of that signaling on the stored information of these things. Yeah. So their information content has changed. Now, as a result of that change in information content, new forces arise. So attraction, repulsion, for instance, which then brings those things together. And then some magic happens, and there's a new form of signaling that takes place, new affordances for relationships. So that's what the 5th part is. So the things have come together, and now they're acting as a whole. But I thought that might be, I don't know where that I'm going, but I thought maybe that might spark some thoughts.
Well, you've turned the diagram round, haven't you? So
I have, yeah.
You've got the functor and the structure.
That's right, yeah. Now, there is a reason why I did that. It's because it's in line with the Kinefin model. So down
with
here,
what model?
the Kinefin model from Dave Snowden.
Right.
So you have perceived chaos down here. Yeah, so there's signaling taking place, but it hasn't yet brought out a meaning. Yeah.
Okay, I'll have to think about that one a bit.
Yeah. And here we've got perceived complexity, which is where we're appreciating systems. Yeah. So this is what's happening here. There's an appreciation which is taking place. Here we've got perceived complicated. Yeah. So we now have interactions taking place between the parts. Yeah. And here we've got the perceived simple, where you have things actually manifest.
Okay.
Yeah. So that's why I rearranged it that way. But it's exactly the same. It's just turned about. Yeah. So this side and this side have switched.
Well, I haven't yet made the connection with how do you say it? Kinefin?
Kinefin or Kinefin.
I haven't made that connection.
Yeah.
But what I've tried to do is to clarify exactly what we mean by the formal, efficient, and material and final causes.
Yeah.
And I need you to be happy with the definitions I've proposed, because they seem to me quite general.
Yeah.
And in a sense, the question of complexity and complicatedness and simplicity derives from the models that we are creating. So for example, I've tried to do Aristotle's dining table example
Yeah.
on the basis of this generic Holon.
Yeah.
And that's as simple as you can get.
Mm.
So on the first slide after the one you're showing at the moment,
I see. Yes.
that is an example of simplicity, really,
Mm.
because it's just common sense.
Yeah.
Everybody knows and understands what it is to think, I need a table. What size do I want? What do I want it for?
Yeah. Yeah.
What do I want it made of?
Yeah. Yeah.
Etc. How do I actually create that table? I'm
Yeah.
assuming you don't go out and buy one.
Right.
You can actually make it. And then having made it, what the consequences are, the new shape of timber was previously just logs and is now a table. And then the final chord is, well, is this a table good enough to eat off and use it as a dining table? If it isn't, you have to circle around again.
Yeah.
So in a sense, that's an example of simplicity
Yeah.
in the Kinefin model.
Yeah. Yeah. So this is interesting. So, you know, I would put the so this is just the way I'm thinking. Yeah, and I might not be right, but the acts of eating at the table, I would put into the material cause.
Sorry, the what you
I'm
think?
just I'm just thinking. The would I do that? Yeah, the actual act of eating off the table, I would have. Now this is really interesting. This is really interesting. So I'm actually wondering if this is exposing what I think might be the thing in the center. Uh, my initial thought was that the act of eating, the actual act of eating, would be in the material cause. Yeah.
Yeah.
And that the desire or the thinking about eating on a new table would be in, you know, the idea of a table and the idea of eating from a table would be in the final cause. And I don't think that's right, but that's what I thought. Yeah.
Well, it's not eating in the sense of eating.
Mm,
If it's
mm,
this, it's eating in the sense, is it suitable for
mm.
eating?
Yes. Yes.
Does it fulfill the criteria
Yeah.
of a dining table?
Yeah.
I don't quite know what the criteria would be other than
Yeah.
the height and the smoothness of the tabletop surface,
Yeah.
um, and whether it fits with the chairs that I've got.
Mm,
Um, and what I've called contextual harmony. That's a new idea from this week,
mm.
which is just saying that it fits the context. In other
Yeah.
words, if you're thinking of a table for your dining room,
Yeah.
it's got to fit in with the aesthetics of that room.
Mm. Yeah.
So that's why I put it that way. So maybe that confusion about eating is that it's really the quality of the table for the purpose of
Yeah.
eating,
Yeah.
not
It,
not the actual act of eating.
yeah. It's the fitness. Okay.
Now, if you come to something that's complicated, um, then if you drop down on the diagrams, I mean, I need you to be happy with the diagrams,
Mm.
but if we think of in engineering terms, designing a bridge down at the end of the list, of examples.
You want me to carry on? Oh yeah.
Yeah, designing a bridge.
Mm.
I did play around with designing an aeroplane there for
Mhm.
you, but
Mm.
I decided I don't know enough about aeroplanes.
Yeah, actually, I'm
So
thinking about airplanes at the moment as well because that's not my
I
home.
do, I do know about bridges.
Yeah,
Now, what it would be good for us to do, perhaps a suggestion would be for you to have a go at something like this,
mm.
but within your experience. So,
Yeah,
a jet engine, even, or um, I don't know what it is that you get involved in on a day-to-day basis.
yeah,
Maybe you would want to sing in terms of a system
yeah,
with big people in it rather than a thing like an engine.
yeah, yeah,
Um, but it would be interesting for me to see you, whether you could get anything out of that.
yeah.
And I would say that this is an example of complicatedness in the sense that um, a jet engine is extremely complicated,
That's right.
but we understand how it works.
Yeah, yeah,
So uh,
yeah,
if you unless you widen the system to take the aeroplane and the whole business of maintenance and running of an aeroplane by an airline and all the it starts to get more complex then,
that's
doesn't it?
right. Yeah, yeah, yeah. As you add more information to the system, you make it more complex.
Yeah.
Yeah,
So it'd be interesting to if
yeah,
you were to have a go at that.
yeah. It's funny you should say that because I did actually have an example in mind. Um, and let's see, I've got it. Yeah. So, did you know Bud? Did you know Bud Lawson? Did you ever come across
No.
it? Yeah. So he was one of the authors of ISO 15288, and he wrote a really great book, A Journey Through the Systems Landscape. It was very systems engineering, very systems focused. Yeah. Um, and one of the things, I don't think he explained in this, don't think he explained it in this book. He gave this in a presentation that I attended. So what he was doing is he was combining the OODA and the Plan, Do, Check, Act loop. And this is essentially what he created. Yeah. So you've got observe, orient, decide, and act, which is the strategic aspect. Yeah. And then you've got the plan, do, check, act, which is the tactical. Yeah. And we've used that at work to basically organize our technical management processes. Yeah. So
Yeah.
so we've got two Holons here, but actually they also form uh, another Holon. Yeah. Of we've got a Holon of the strategic and a Holon of the tactical. And when so in the context of technical management, when we're observing, it's who are the stakeholders, what are their needs and concerns, making sense of the information, what is the purpose of the development. Yeah. Then there's the orientation, which is what is the situation, what's the scope, industrial framework, how complex is the development, what are the issues and risks. And then we're deciding where do we want to be, what are the key success criteria, and what's the strategy to get there. And then we're being more detailed in terms of our planning, in terms of what's the scope of each iteration phase, what's the structure of the development in terms of the PBS, WBS, OBS, that kind of stuff. What are the necessary work products? What work has to be performed and by who in terms of the tasks, and how is this all joined up, and then determining the schedule and costs. So that's the basis of the systems engineering management plan, or as we call it, the technical management plan. And then we go into the day by day, week by week management of the team, which is keeping an eye on the progress metrics, and Kanban boards and all that kind of stuff. keeping the team focused on generating values, ensuring that interdependencies are respected, promoting collaboration across disciplines and teams, being visible, proactively dealing with questions and issues. What technical performances are expected? Are the deliverables completed on time? Are there conflicts, trade-offs to be made? Are things coming together? Are the customers in the value chain satisfied? So this is where we're being, sort of agile in the management of the team. And then this side is all about the establishment of the technical baselines, and confirming that what has been defined in terms of the milestones, the key milestones, is being achieved. And all of these things are constantly interrelating.
Yeah.
Yeah. Now, sorry, go ahead, David.
Well, we touched upon this in the paper with John.
That's right. Yeah.
Patrick. And I think it's entirely compatible.
Yeah.
What Patrick and I did in our book is to take an approach that's very similar to what you're describing there, and see it in terms of Holon's, with the basic attributes of who, of why, how. Well, why is the potential that drives the change in flow. The change is the how, and the flow is the who. There's the people involved. The what, that's the thing involved. The where and the when, which is the context, and the timing. So I'd like to have a copy of that diagram there.
Yeah, I can send it to you.
And write it in those terms so you could see that's how we were doing it. The issue with John Kinnaman's paper was how to connect that kind of common sense engineering approaches, if I may put it that way, with this more fundamental scientific approach that we've got out of John with the relational holons. And so, we started to make that connection in the paper, didn't we?
Yeah.
But maybe we didn't develop it sufficiently. We need to develop it a bit more.
Yeah.
With examples.
Yeah.
That it'd be interesting to see if we could translate or relate the diagram that you've got on the screen with the one I wrote about designing a bridge.
Yeah, that's what I thought. That's why I thought I'd show it.
I think it's a question of interpreting the attributes.
Yeah.
Yeah. As a program manager, you're very concerned about progress, about the people being, if you like, competent to keep the deliverables coming and getting agreement between the various stakeholders as to what you're trying to deliver.
Yeah.
So all of that, all that integration needs to be captured and in the end decisions made at stages in the progress of the project when you can make key intervention.
Yeah.
So I think that if you could send me a copy of that diagram, I'll have a look at it and see.
I will do, yeah.
I mean, I've put in various publications a Holon diagram. Could you show the one before, the one that was on the screen that you showed me before, of the two?
That one?
Yeah, the one on the right. I've produced a diagram which is similar to that, a little bit different, because I can't just remember exactly, but I identified the fundamental things that you have to do in order to make something successful. So the first thing is lay the foundation.
Yeah.
As a civil engineer, foundations are important.
Yes. Yeah.
And so philosophically, what you are trying to do is to get a strong, firm, philosophical, practical foundation for higher level activities.
Yeah.
Not higher level in terms of difficulty, but higher level in a hierarchy.
Yeah.
And I think I had them as laying the foundation, and then, oh, I know, creating a structure. That was my usage of the terms at the time, but I think maybe need to change that in the light of what we've found together. But it's basically having the organization, the order. If you take it from Estonia, then having the organizational knowledge, and the final one was working well. In other words, doing what you want it to do.
Yeah.
So I had 3 circles, like you've got 2 there, and I put one at the bottom, which was the laying the foundation, and the 2 at the top was getting the structure, organization in place in order to deliver something that would work well.
Yeah.
So maybe we can integrate those ideas into to one diagram.
Yeah.
But we're obviously aiming at the same thing.
Yeah. It just depends how much we can get into one paper.
Yeah.
I think we. I mean, this, to give the whole thing full justice. I mean, we're probably talking about a fairly big book. Yeah, and what the way I see we're going is we're biting off logical chunks. Yeah. And I think the first paper that you did was a really strong starting point. Yeah. And now we're taking that next step. Yeah. I think we've got to be careful we don't take too many steps at once, but we've also got to make sure that we get enough in there so it's actually relevant and understandable.
Yeah. Well, I think the conceptual gap in the philosophical mathematical terms between somebody like Bud Lawson.
Yeah.
If I'm only reading what you've given me, so I don't know him. The conceptual gap between him and John Kinnaman is actually quite large.
Yeah.
But the bridge between them is there.
It is, yeah.
It's just that they're looking at it differently. And, all my academic life, I've had to grapple with the academic mathematical types who want everything to be mathematized.
Yeah.
Through to, I've worked with structural engineers who design bog standard buildings in Bristol. A good friend of mine is a consultant, or was, he's retired now, who has his own practice. The younger chap's taken over now. but they do standard building, so there's nothing really that complicated about them, other in the technical sense. But in the actual practical sense, as something like Grenfell demonstrates, they are actually incredibly complex because there's so many parties involved, from architects to building surveyors to financial people, structural engineers and civil engineers doing the foundation and so on. There's a lot of people involved. And now, of course, fire engineering used to be very simple. You just used to put cladding on the steel and leave it to withstand the fire. But now you've got fire doors and compartmentization and all sorts. So the system, which failed at Grenfell rather dramatically, because on top of all that, you've got the residents and their behavior and things like they take the fire doors and open them because they're heavy, and prop them open, which of course stops them from working. And most of the time it doesn't matter. It's when you get an emergency happening and a fire spreading, which is pretty rare, but it does happen.
Yeah.
So these systems are actually quite complex, but we only are trained to think about them in a very simple way. And each bit of it, the structure is very simple, really, and it's just bending moments and shear forces and so on. And that's the end of it. But when they're having to do with the whole thing, it gets quite complicated. So, they are the people trying to approach this problem using the sort of thing that they've understood, and now suddenly people are telling them about systems engineering, and that's the answer to everything, and they really don't know what they mean. They don't really understand what systems engineering is about. Other than it's holistic. Yeah, what does that mean? So our attempt is to build a model which is both reductionist and holistic at the same time. With the holarchy. So I think bridging the gap between the mathematical types and the practical types needs people like you and Patrick, who clearly are able to think much more broadly than perhaps you were trained to do originally with your degree, and to communicate that better understanding to people who are not capable of generating it themselves. So it's tricky. It's tricky to satisfy. When you write a paper, you get a referee who's a mathematical type, thinks it's rubbish, whereas a referee who's a practical type thinks it's too theoretical. And that's refereeing. That's the problem with refereeing that we suffer from. But of course, you have to keep at it, and as you keep at it, you get to use a language that each side can begin to understand. So that's why, in terms of Kuhn's paradigm shift, we're moving the paradigm. And that's difficult.
That made a lot of sense, and you were very eloquent the way you were expressing that. What I find interesting is that you'll still be building bridges. But now you're not building physical bridges, you're building philosophical bridges.
Well, that's the title of one of my books.
Oh, okay. Okay.
Building bridges between
Oh,
theory
of
and
course. Yes, that's the one I've got actually. No, it's not. That's not the one I've got. I've got this one. I've got creativity, problem solving, and aesthetics in engineering.
oh yeah, that's the
Yeah.
third one.
Yeah.
Yeah, I wrote a book called Building Bridges
Okay.
for Oxford University Press, which is
Right.
just about bridges.
Okay.
Um, but then I wrote the Building Bridges Between Theory and Practice,
Yeah.
which is published by World Scientific Publishing. And then the one you've got there is the one I was trying to um, write about what engineering is.
Yeah.
Uh, and to get people to think more broadly than it's just about number crunching for engines and bridges.
Yeah.
It it needs to be conceived much more broadly in the way that you obviously do and Patrick does, but not a lot of people do in this world. Anyway, okay, so where to now? What time is it? 9:36. So okay for another half an hour.
Yeah. It might be worth
That one is puzzling me. That one,
this one here.
no, the one before. I need to think. I need a copy of that and think about it.
Hmm. Yeah. Well, I'll send you the links over. This one was interesting because within the ISSS there's a medical doctor who bridges Chinese and Western philosophy in his medicine. So he uses the five elements. Yeah, and those five elements also map to the relational Holon. But there's a fifth element which is metal. And it's the metal, the product, um, which sits in the center. So you know, informational events are water. Structured information is wood. Fire is forces. The mass and energy of material things is earth. But the actual product is metal. And what's interesting in Chinese medicine is that there's this cycle which is consistent with the cycle of the Holon, but also they have overcoming interactions. So fire overcomes metal, metal overcomes wood, wood overcomes earth, and earth overcomes water. And I think at some point it might be worth looking at these overcoming relationships because they may help us in practical problem solving. You know, when we're looking for leverage, for instance. Yeah.
When we're looking for what?
Leverage. When you're looking for
Yeah,
leverage to change something, I think that these overcomings may be an indication of leverage. Yeah.
yeah,
That's what
yeah.
I'm thinking. I haven't got anything to back that up yet, but intuitively, I've got a feeling that that's right.
Well, immediately, perhaps wrongly, I'm thinking of vulnerability. In a sense, the leverage thing is finding the factors
Mm,
that will influence the outcomes you want
mm,
most effectively.
yeah.
So, for example, I had a colleague who used to complain about everything to our head of department.
Mm,
And I said, Roland, the trouble is you've got a reputation for complaining about everything. What you need to do is to think about things that are really important and just complain about them. Then you might be more effective. So it's kind of effectiveness. Now, the reason I was thinking about vulnerability is that one of the neglected aspects to systems is how to identify how they're vulnerable. In other words, the weakest link. We've applied this to road transport, for example. If you think of a city like Budapest, one part of the city is on one side of the river, and the other part is on the other side of the river. Now, therefore, the links, the bridges over the river are actually critical to the success of the whole system. If you have a blockage or a breakdown in those, say there's just, I don't know how many bridges are in Budapest, so I idealize it to something where there's just two. Then those two bridges define actually what goes on in the rest of the system. And if they get blocked, then you don't bring the whole thing down, but you do cause an enormous amount of damage. The system's functioning. Now, sometimes, as in the case of the river, those weak links are obvious. You don't need anybody or any analysis to understand that. But in a more complex system, then these vulnerabilities are not clear. And you need a kind of network analysis to find them. Now, what you're talking about there is kind of reverse of that. It is what connections are the most effective in inducing the change that you want to see.
That's right,
So that's interesting, perhaps you could send me that slide as well.
I will do, Okay. Right. Okay, so my target for this morning will be to read through the words and come back with comments. And I'll also.
Carry on then. We've got entailment.
No, I haven't made any more comments on this yet. What I'll do is I'll read through the rest of the document, and I'll put in some questions or any reflections that come to mind.
Okay.
I'll do that.
I've tried to be as logical
as
it can be.
In
other words, by building up the concepts. So you'll see that some are bold and some are italicized. The ones that are italicized will be later defined.
Okay, that makes sense.
So number 7 is a Holon is an organized relation. On his own, that doesn't really mean a lot, does it? So you have to scroll down and find what an organized relation is.
Nice.
And the same with an event as a signal. So I've tried to be as logical, but if you feel that there's a need to change that and it's not as logical as it could be, then please suggest changes. It's only a draft.
No, I appreciate that. And I think it will trigger questions in my own mind about things as well. No, it's good.
The other thing that I mentioned in the email, which has really changed my thinking quite a lot, was the idea of a I've forgotten what the phrase is now. Oh, information machine.
Yes.
I sort of glossed over that a bit when I read it first time.
Yeah.
But I've realized that that concept is extremely important.
Yeah.
In making the links that we want to make.
Yeah. Yeah.
Because in the book, Donia says that an engine is an information machine in the sense that the shape of the engine itself is the way that the energy is managed
Yeah.
to achieve the outcome
Yeah.
that you want to get.
Yeah.
I'd never thought of it quite like that before.
Yeah.
So he talks about it in physical terms like that, and he talks about it in biological terms.
Yeah.
With respect to cells and molecules.
Yeah.
But he doesn't mention social
Yeah.
system.
Yeah. Yeah.
And
which are, of course, as well.
so I'm seeing a design team as an information machine.
Yeah, agree. Yeah.
They're organizing the world so that the energy will be used in the way to achieve the purpose that they are setting out to try to achieve.
Yeah.
I think that's a big insight.
Yeah. No, I love it. I mean, I had a similar realization when I was reading the book that you know, when we do our model-based systems engineering, we're creating an information machine, which is an abstraction of what will be the real information machine. Yeah.
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 Yeah. I mean, it's
we're creating an information machine to create an abstract information machine.
it's organizing the world.
Yeah.
To control the energy in the way we want to.
Yeah.
Do. Yeah. To achieve a purpose.
Yeah.
So I think that's really, really important.
Yeah.
And not an idea that many people will have in mind.
Yeah.
And so people will say, well, so what?
Yeah.
But the book, you and the book changed my view of information considerably. And in fact, the one thing in the book that triggered in my mind was when he refers to Newton's laws.
Yeah.
And says you've got energy information in there, and you've got energy in there, and you've got information in there.
Yeah.
And I never thought of three-dimensional space and the vectors as information before. So we've got to, when we do write a paper, we've got to be very, very clear right at the start as to how we are defining what information is.
Yeah.
And I suspect that was the problem you had with your paper.
Yeah, I was making too many jumps.
Because they would be thinking perhaps about information rather like I was before I realized what you were pointing me to.
Yeah. And
I think there's a big step there to be made before you can really understand what we're on about here.
Yeah, absolutely agree. Yeah.
So the question, Gary, really will be when do we start writing a paper and what are we going to put in it? I think we're not quite there yet because we need to just shake out these understandings that you have raised this morning. I think maybe that Chinese medical one could be further down the line. I'll start to give that some thought.
Yeah.
But the earlier ones, if we can make a connection with kidney fin, that would be quite powerful, wouldn't it?
You would, yes. Yeah.
Or do we want to leave that alone for a while? I don't know.
I think that's one of the decisions we'll have to make. Just how
I think
far,
the one
how far
thing
do we
that
go?
we could sort out is the diagram you just showed me with the plan do act and
the technical
the
management.
two
Yeah,
yeah. If we could make an inroad into that,
yeah.
clarification of that could be enough for the paper,
I
couldn't
think
it?
so. Yeah, because what we're essentially doing is we're taking what we've done before. We're now making the next step, which is starting to look at more of the details of the mechanisms and being more clear on the information in those different spaces. And then from that, we're then moving into something which is strongly practical, which is how we build teams, yeah, and manage teams with technical management.
Yeah.
Yeah.
Um,
And we could perhaps hint at the relationship at the end with the Holons and chaos, complexity, complicated and clear. Yeah. Just hint at it. Yeah. But not go into the details of it. It's kind of
well,
like this is
what I
what's
said
coming
earlier,
next.
what I said earlier about complicated and simple.
Yeah.
If we had a number of examples of the kind that I've sent you,
Yeah.
then the Aristotle one can be an example of simpleness. The bridge or some other example, the engine, could be an example of complicatedness. Then I think we would have to describe complexity by having a number of connected holons,
Yeah.
which model a more complex situation without necessarily, sorting that one out fully.
Yeah. Stonius.
Fourth, what's the fourth one?
It's clear, complicated, complex, and chaotic. Yeah.
Chaotic.
Yeah.
Well, chaotic isn't a problem in my mind because that's to do with the non-linearity and sensitivity to initial conditions. I'm not sure that really follows from what we're saying here, other than it's more it's a set of physical thing.
Yeah. The Snowden model really refers to perceived.
With what, sorry?
It really refers to perceived chaos, perceived complicated, perceived complex, and perceived clear.
Yeah.
Yeah. So it's taking the perspective of the observer of those different situations. Yeah.
Well, clearly, some systems are chaotic, and in that they are exhibit certain behaviors, like
they exhibit
wandering around the phase space.
They exhibit very unpredictable behavior.
I'm not sure that there's a fundamental difference in the terms of the structure of the information and the energy.
Yeah, if you look at it from an information perspective, it's quite interesting and potentially useful, I think. Yeah. So from the perspective of the observer, chaotic systems are where you are receiving information, but you cannot yet organize it. Yeah. Com complex is where you've organized the information and you can now appreciate the system. You can now see it as a whole. Yeah. So Stoner says that if you have an established system and you add more information to it, it becomes more complex. And if you then follow that line of reasoning, and you think about the complicated, the efficiency of how the information is stored is directly it's inversely proportional to the complicatedness. Yeah. So the more efficiently the information is stored, the less complicated it is.
Yeah, because the more ordered it is.
That's right. Yeah. Yeah.
Yeah. Gary, I think we better stop in a minute.
Yeah.
Let's just summarize what we're going to do. You're going to have a look through all the text.
Yeah.
Send some comments.
Yeah.
Can you send me those diagrams?
I'll send you the diagrams, yeah, and I'll also try and split up the technical management diagram into the 4 causes.
Yeah, and have you got any references to Lawson's work?
Yeah, I've got his Exploring the Systems Landscape book. Well, I can give you the link to that. I don't have a copy of it myself.
Has he written any papers which would summarize it?
I'll take a look. I'll see if I can find them. Yeah.
Because if they are, then we can get those on.
I'll see what I can find. Yeah. He was.
I've come to the limit of how many books I can buy.
Yeah. No, sure, I understand. Yeah. Yeah. Bud was the inventor of the mouse.
Yeah. The other thing is for you to see you can make sense of this example that I've sent you, and translate that into an example that means something to you. Maybe it would be the technical management.
That's what I was hoping. Yeah.
Or maybe you could start with something more clearer, like an engine. I mean, we know how a jet engine works as a turbine.
I don't.
How would you express that in the way I've talked about a bridge?
Yeah, yeah. So I'm a process person, really.
You're not telling me you don't know how jet engines work, though.
I don't. No, I don't. I don't know how a jet engine works. I can find out. I'm sure I can find out and understand it, but I don't know how a jet engine works.
Well, anyway, whatever grabs you, whatever you think is useful.
Okay.
Doesn't have to be a jet engine. I'm just trying to think of something simple.
Yeah.
Something is relatively straightforward. I know a jet engine isn't simple,
yeah,
but the understanding of how a turbine works is something simple that you really wouldn't have a lot of trouble in understanding.
Okay.
And then something a bit more challenging, like the technical management.
Yeah.
Which you may change your view of it as you draw the diagram. Don't know. But anyway, to have a go at that, because I think something of that kind would be very valuable to include in the paper.
Okay. I'll give it some thought. I've probably got an example somewhere. Yeah. All right.
Yeah. The other thing that you could do is If you could send me what you think the purpose of our paper is and what things we're bringing together in it, we want to bring together. Clearly, one is relational theory.
Yeah.
Two is PDCA or whatever it is called. Yeah. And what else do you think would be, we should be including?
Yeah. Okay. Yeah.
Can you do that? Okay.
I will do. Yeah.
Yeah. And you'll send me a recording of this, of course.
I will do. Yeah.
Do. Yeah. Okay, Gary, I must go because it's 10 o'clock.
Thanks, David.
But I've got a COVID jab later this morning.
All right. Okay. Well, good luck. Okay.
Yeah.